Hi, my name is Luís Philippe. In this tutorial, I will try to show how to create and optimize a trading algorithm with machine learning applied to several securities without any expensive software and using only the power of PHP, JavaScript and HTML. If you want to try the code I will demonstrate, you will need to install a web server packaged with PHP, which can be done easily and quickly in any laptop or desktop PC. There are some free web servers available packaged with PHP. I am using AMPPS, which is automatically configured during installation and so is ready to use after installation. But you are free to choose a different one, provided it includes PHP. We will need a database with the price and date of the securities we want to analyze. You can use any time interval in your analysis. I prefer to use the weekly time interval because it reduces price noise and is less prone to errors. For a faster process, this database will consist of TXT files with comma-separated data. I will analyze roughly 100 securities and each security data is stored in a separated file. To simplify, I will use the well-known simple MACD technical analysis indicator. MACD is a widely used technical analysis study among securities traders to find investment opportunities in financial markets. It is commonly used along with other technical studies to find divergences and convergences because it's how it's more efficient. As the main purpose of this video is to show how you can create and optimize your own trading algorithm with machine learning, I will use it in this tutorial without any other study to analyze possible profitable signals. And if you are really interested and serious about trading securities, I advise you to study markets behavior and fundamental analysis and create your own analysis model. MACD is the difference between two moving averages, a short-term moving average and a long-term moving average. The most commonly used are exponential moving averages, which place a greater weight on the most recent price and react faster to price changes. The signal line is a moving average of MACD, normally with a period equal or lower to the short-term moving average. In our analysis, we want to buy any security at market price when the MACD is below zero and crosses above the signal line, and sell the corresponding security also at market price when MACD crosses below the signal line. So we will start by creating a function called MACD that will return the values needed. We need to declare the short-term period, the long-term period, and the signal line period. I'm going to declare the smoothing factor, which will be equal to 2, a standard value, a variable for short-term exponential moving average, another variable for long-term exponential moving average, an auxiliary variable to calculate signal line exponential moving average, an array to store the last two values of signal line exponential moving average, an array to store the values for the observation period of the signal line, an array with the close price during the observation period of the short-term period, and another array to store the closing price for the observation period of the long-term exponential moving average. We need to pass a variable to our function MACD, which we will call bar counter, and all variables and arrays must be reset when the bar counter is equal to 1. Then, we need to declare conditional statements to start to fill the arrays of the exponential moving averages observation periods right after receiving the first closing price. We also need to pass the closing price to our function MACD. Then, we continue to fill the arrays with the last price, but in order to get a faster execution and release memory, when bar counter is higher than the exponential moving averages observation periods, the first element of each array must be removed every time the MACD function is called. But before we remove the first element of each array, we need to calculate the exponential moving averages. For this, we need to wait for and account one more observation point to add more weight to the most recent price. For example, to calculate a 10-period EMA, we need 11 observation points. The first 10 are calculated as a simple moving average multiplied by a factor and correspond to the previous closing price EMA. Then, this value is added to the current closing price multiplied by another factor. Now that we have the short-term and long-term moving averages, we can calculate the current MACD value and store it in the MACD array. As we only need the last two MACD values, we remove the first element of the array whenever a new value is added and the array dimension is higher than 2. Here, we are going to declare a conditional statement to calculate the signal line exponential moving average. The signal line can only be calculated when the variable bar counter is equal or higher than the sum of the periods of the long-term exponential moving average and the signal line exponential moving average. To simplify the code, I decided to start calculating, fill the signal line array with values, and remove the first element of the array only when the bar counter is higher than the sum of the periods mentioned. Now we are going to return the values needed in the form of an array. The function will return an array with the last and the previous value of the MACD and the last and the previous value of the signal line. Now, we are going to declare a function that will define the optimization settings. We need to define the observation periods to map all the settings for each of the MACD variables. For example, we want to run an optimization of the MACD with the short-term EMA ranging from 3 to 9 periods, the long-term EMA from 8 to 16 periods, and the signal line from 3 to 5 periods. We store these ranges in arrays, but first we need to define some conditions. In this tutorial, we want the long-term EMA period to be always higher than the one of the short-term EMA, and we also want the short-term EMA period to be at least equal to the signal line period, so we cannot simply multiply the observation periods to find all the settings. Instead, we need to run an iteration with the conditions, as this is the only way to automatically map all the settings for every observation periods we define. In this function, we define if we are running an optimization process or a fixed setting process. For that, we assign a Boolean value to the variable defined optimization. We declare a variable called iterations, which will have an initial value equal to 1, and an array called array settings, which will store arrays with all the possible period combinations given the ranges we define. Next, we declare a conditional statement to evaluate if the defined optimization variable is true, and if it's true, we assign the zero value to iterations variable and declare the ranges of the arrays of the short-term, long-term, and signal line moving average periods. Then, we declare three nested for loops, one for each moving average. For each cycle, we store each optimization setting and add one more unit to the iterations variable. This function will return an array with three elements. The first element is the defined optimization variable, the second is the iterations variable, and the third element is an array with the optimization settings. Now, we need to change the MACD function in order to evaluate if we are running an optimization process or an analysis with the MACD fixed settings. When we run an optimization process, we want to find the total results for each setting, but when we run a fixed setting process, we want to visualize the details of each trade of every security. We need to call the optimize MACD function, and for that we will use a variable which we will call optimization and we will pass to MACD function as an argument. We also need to pass another variable which we will call ZZ and will be used in the main loop as a counter. We need this variable to use as a key to get the optimization setting from the array settings. Next, we will declare a loop. But before that, we need to increase the script execution time, which we will define as 10,000 seconds. We are going to declare a variable to assign the path where our data files are stored. We are going to declare the main for loop. Then a conditional statement to evaluate if the directory exists. Then one more conditional statement to evaluate if the directory is open. Now we are going to declare a variable which we will name trades counter, another which we will call cumulative gross profit, another call it gains, another call it losses, another variable we will call winning trades, and another call it losing trades. Next, a conditional statement to read all the files stored in the folder. And now, a conditional statement to describe our data files names. All the files names have a unique name, starting by their ticker, and all of them have the same suffix, which in my case is data. We are going to assign the file open function to a variable which we will call txt file, then a variable called position with an initial value equal to 0. This variable will be equal to 1 after the system triggers a buy signal and equal to 0 after a sell signal. Then we need to declare the open price, open date, close price, close date, and the sell bar of the position, and the variable we will call bar counter with an initial value of -1. We will declare a while loop which will be repeated in each line of data of the current file. Then we assign the fgetCSV function to a variable we will call line that will read the file contents line by line. Then a conditional statement which will be executed when bar counter is higher than 0, which means when the file pointer has read the file header and is now reading the codes. Now we will declare a variable called MACD, which will call the MACD function. When calling the function, we need to pass the bar counter, the close quote, the optimization, and the double Z variables. Next, we need to declare the buy and sell conditions. These conditions will trigger buy and sell signals if the security price meets our criteria. We will define a buy signal when MACD crosses above the signal line and is below 0, and we are only interested in securities trading at a price higher than 1. And we will define a sell signal when MACD crosses below the signal line. Next, we need to declare conditional statements for the buy and sell signals. These conditions must be placed before the price evaluation because in our case, we want these actions to take place at the open price of the next bar, which means an order at market price. This is particularly important to accurately measure the ability of our model to generate profits, because by placing buy and sell orders at the open price of the next bar, we will get the most reliable results from our analysis and the most approximate trading simulation to real conditions. At every session opening, there's always a high liquidity in the market, with many buy and sell orders from many market players. So it's very likely that our orders would be executed exactly at the open price. Therefore, we can disregard price slippage in our analysis, and we don't need to define a random slippage that certainly would be an inaccurate value. Now we need to update some variables that will store the results of our analysis. In this tutorial, we only want to determine trading dates, prices, gains, losses, and profits, but there's an almost infinite amount of data that we can define and display in the analysis report. For example, we may want to know the maximum run-up and drawdown of all trades, or we may want to determine the Sharpe ratio, the risk-return ratio, or the expectancy ratio, or the outliers trades. There's a wide range of key performance indicators that help us determine how reliable is our analysis model. We can even analyze a security correlation with a benchmark like the S&P 500 or Dow Jones Industrial Average. We have already used a variable called optimization in our code, but we didn't declare it. This variable will call the optimize MACD function all in once in order to calculate the optimization settings in the beginning of the script execution and will be used to return the parameters previously described. We will declare this variable before the main loop. Next, we will declare a string which we will call multi-stock analysis table head. To this string, we assign HTML code to define the head of the table where the analysis results and all the individual trades of a fixed setting process will be displayed. This table head will show the security ticker, trade open price, trade open date, trade close price, trade close date, the cumulative number of trades, the profit or loss per share, the gain or loss in percentage, and the cumulative gross profit. Now we will declare a string called style. This string contains CSS code and will be used only when we run an optimization process. When the optimization process is complete, the results table will be sorted by gross profit using JavaScript. Only then the table will be shown. This may take some time depending on the amount of data to display. Next, we declare a variable called optimization multi-stock analysis table head. To this string, we assign HTML code to define the head of the table where the analysis results of a fixed setting process will be displayed. This table head will show the gains, losses, gross profit per share, winning trades, losing trades, total trades, and the MACD short-term period, long-term period, and the signal line period. In these conditional statements, we will also declare a new variable called background color, which will be used to style the results table. Then, we declare a string called ticker results. In this string, we add individual trades and individual and cumulative results of each security during a fixed setting analysis when the sell bar variable is equal to bar counter. At the end of each security analysis, these results will be added to another string and then reset to null for the following security analysis. Here, we declare a variable called total tickers, which will be incremented with the ticker results values. After this, the ticker results is then reset to null. Here, we output CSS and HTML code to display the analysis table in the browser with an echo statement. At the end, we add the total tickers results string and close the HTML tags. Next, we declare the conditional statements for the case when we run an optimization process. Here, we declare a new variable called total tickers results, which will be incremented with the total analysis results of each optimization process setting along with the HTML code. Now, because the optimization process can take several minutes or even hours to complete, depending on the ranges of the observation periods we define in the optimize MACD function, we are going to create a progress screen. For this, we need to assign an execution progress value to a variable which will be called progress. At the end of each main loop iteration, this value will be sent to the browser in an HTML element with an ID. In order to output data to the browser during script execution, we need to call the functions output buffer flush and flush after the echo statement. And because the optimization process can take too much time to complete, we are going to create a code that will save the optimization report so we can see it whenever we want without needing to execute again the whole process. We assign the function file open to a variable called report, declare the file name, and then we call the file write function and declare the contents we want to write in the file. Now we are going to code the progress screen in JavaScript, which will be composed of a progress circle with a progress percentage in the middle and a message below with an animated ellipsis mark. I'm going to use a new document to write the JavaScript code, and then I will copy and paste it as a string in the PHP script and assign it to a variable called showProgress. We will create a fixed background circle with a dark color, a foreground progress circle with a light color, a percentage value in the middle of the circle, and a message below. We start by creating a function called showProgress, which will be called in the beginning of the process. Inside this function, we define all the JavaScript code. We set the background circle dimensions, and then we create the foreground circle, which will be a path, the progress percentage text in the middle, and the message text below. Then, we create a function called updateProgress, which will include the set interval functions needed in order to update the execution progress in the progress screen elements. We also need to code the script that will get the element output by PHP with the progress value. Here, we are going to create a function called updateWaitMessage, which will be called in the timingWaitMessage setInterval function. This function will use a counter called "Z" declared in the beginning of the script. Then we create a function called updateProgress that will receive the variable progress as an argument from the time-even setInterval function. We create another function called adjust that will return a string depending on whether the progress is higher or equal or lower than 0.5. And when the progress is equal to 1, we need to define the progress as lower than 1 in order to get an almost 360-degree circle, because 360 degrees is the same as 0 degrees, and in this case the circle would simply disappear. Next, we create the HTML elements where the circles will be printed. We will create an SVG element which will cover all the screen. Inside the SVG element, we create a circle element for the background circle, declaring an ID, the stroke color and stroke width. Then, we need to create a path element for the foreground circle, also with an ID, the stroke color and stroke width. We declare the initial state of the progress circle with a hidden element. This hidden element is the same as the one output by the PHP script during the optimization process execution. After the JavaScript gets the element and reads the progress value, the element is deleted. Now, we are going to copy this code to the PHP script. We need to create another script in JavaScript to sort the optimization results by gross profit. We will assign this script to a variable called sort results. There's only one section I would like to explain. Right in the beginning of this script, there's a code to get an SVG element and delete it. This SVG element is a progress screen. When the optimization process is finished, before the results table is shown, we need to remove this SVG element. Now we need to add a conditional statement to output the style in the progress screen code. If we are running an optimization, we declare echo statements to output the style in the show progress variables. This conditional statement must be placed before the main loop. Next, we need to add the variable sort results to the file write function in order to create the report file and also to a new echo statement to display the results. We also want to display how long did it take the execution of the optimization process. For this, with a simple calculation, we can show the execution time in hours, minutes, and seconds. Now I'm going to solve some bugs. The machine is always right. I guess here the array keys are missing. Yes. There's something here. The ID is not correct either. The progress value word wasn't correct. Now here on the progress screen script, I guess there's a curly bracket missing here on the function. Yes. Yes. I'm going to put this back, and at the end I think there's an extra curly bracket that shouldn't be here. Sure. The equation of the var index is not correct. The multiplication signal must be replaced by a plus signal. Here is missing node. This is not correct. It should be set attribute node. Here, and also here. Now PHP doesn't complain, but your right declaration wasn't correct. Now here I'm going to modify these variables formatting. I want all the floating numbers to be displayed with 2 decimal places, so I need to change the code here. I'm just beautifying the presentation. And here too, I want this value to be displayed with 2 decimal places. Also here, and here too. Here I'm adding an equal sign, just to fill the background color in case the close price is equal to open price. Here I am changing this, I'm removing the end word and adding a comma. It's more correct. I'm also forcing this number to be displayed with 2 decimal places. Finally, we are now ready to try the script. We are going to run a simple analysis with a fixed setting. The short-term EMA is defined as 3, the long-term EMA as 6, and the signal line EMA as 3. I will open the browser and run the script. The analysis execution took about 4 seconds to complete. You can see all the trades that would be executed based on the buy and sell conditions. As expected, we can see the tickers, dates, prices, the trades number, gains, losses, and the cumulative gross profit. I'm going to scroll the page to the bottom to check if all the cells are filled with data and if all the gains and losses cells are filled with a colored background. As we can see in the last row and at the extreme right column, this strategy would have generated a gross profit of $7,060 per share. Now we are going to run an optimization process, and for this we will set the define optimization variable to true in the optimize MACD function. I paused and resumed the video recording several times during the process execution to spare you from this boring step. It took several minutes to complete. Now we can see the total tickers results grouped by the MACD settings and sorted by gross profit. The maximum gross profit shown is less than the 7,060 because the minimum long-term EMA period defined is 8 and not 6 like when we run a fixed setting. I'm going to change the period range in the ST interval, LT interval and signal line interval arrays in the optimize MACD function and run again the script. Now the maximum gross profit is equal to the one we got with the fixed setting of 3, 6 and 3. At the bottom, we can see the execution time. So, our strategy would have generated roughly 7,060 US dollars per share. If we have bought 100 shares on every trade, we would have gained about 706,000 US dollars. For a 2 cent per share round-trip commission for every trade, the commission's costs would total 17,070 US dollars. But 100 shares seems a very low investment on securities trading at historical low prices, right? And what if we change our position amount depending on historical volatility and include benchmarks, prices and trends in the individual securities analysis? Now, this would require a new and better strategy. This tutorial was a basic demonstration of the almost unlimited potential that PHP offered to easily analyze hundreds of securities simultaneously and create a non-biased trading algorithm. I used to say for myself that the limit is my imagination. Securities prices are not random. Time is as important as price. When joined, we can detect patterns and trends that repeat in time. Securities don't rise nor fall forever. Their prices oscillate in time and tend to develop in cycles. With this in mind, We need a comprehensive study of markets behavior and solid math knowledge in order to be successful in the world of financial markets. PHP allows a very fast data reading and processing. With PHP, the securities database is easily maintained. We don't need to import any data like in a common technical analysis software. We just put the data files in a folder and simply declare the folder URL. Also, we don't need to compile our code every time we change it, which makes the developing time much shorter. The analysis results can be stored in files for reference and used by algorithms and can be accessed quickly and without needing to pause procedures nor importing new data. And with the help of JavaScript and HTML, we can easily create detailed reports with charts and display them in the browser. Thanks for watching.